Other normal probability distributions. The diagram below shows a number of normal probability curves with different means and different standard deviations. The following explanation shows how we can transform any normal distribution so that the standard normal tables can be used to calculate probabilities for any normal distribution. Part 1. Translating. Suppose x is a normal random variable with a mean of 3 and a standard deviation of 1. What is the probability that x is less than or equal to 4.5? First of all, the standard deviation of x is 1, which is the same as that of the standard normal distribution. So if the x curve is translated or moved 3 units to the left, we will get the standard normal curve. Because remember, the standard normal curve has a mean of 0 and a standard deviation of 1. To achieve this mathematically, we let the new random variable z be defined by z equals x minus 3, because we want to translate 3 units to the left. So that's where the minus 3 comes from. Then z will be normally distributed with a mean of 0 and a standard deviation of 1, the same as that of x. Thus z is a standard normal variable. So this is our original curve. We have a mean of 3 and a standard deviation of 1, and we're going to move our curve 3 units to the left so that the mean is 0. So this point here was 4.5. And if we're moving our curve 3 units to the left, then we subtract 3 from the 4.5 to get 1.5. So moving this 3 units to the left, we would end up at 1.5. To find the probability that x is less than or equal to 4.5, we need to convert x equal to 4.5 to the corresponding value of z. So if x is equal to 4.5, then z is x minus 3, which gives us 4.5 minus 3, which is 1.5, as above. Thus, the probability that x is less than or equal to 4.5 is the exact same as the probability that z is less than or equal to 1.5. And from our tables, we get 0.93332. So again, 1.5 in our tables, we've got 1.5, and we go across to get 0.9332. Part 2. Scaling. Suppose x is a normal random variable with a mean 0 and a standard deviation of 2. What is the probability that x is less than or equal to 4? X has the same mean, 0, as a standard normal distribution, but its standard deviation is 2 rather than 1. So if we divide x by 2, we will scale the graph so that the standard deviation is 1, because 2 divided by 2 is 1, which is what we want for the standard deviation, the same as that of the standard normal distribution. To achieve this mathematically, we let the new random variable z be defined by z equals x over 2. Then z will be normally distributed with a mean of 0, which is the same as that of x, and a standard deviation of 1, which is what we want. A mean of 0, standard deviation of 1. Hence, z is a standard normal variable, and the tables of values can be used to calculate probabilities. So to find the probability that x is less than or equal to 4, we need to convert 4 to the corresponding z value. So when x is equal to 4, z will be x divided by 2, which is 4 divided by 2, which is 2. Thus, the probability that x is less than or equal to 4 is the same thing as the probability that z is less than or equal to 2. So we go to our tables and we get 0.9772. So this was our original curve x with a mean of 0 and a standard deviation of 2. And dividing by 2, we have scaled our graph, where we have shrunk the graph. So we still have a mean of 0, and then we have a standard deviation of 1. So again, z less than or equal to 2 from the tables we see is 0.9772. Part 3. Converting to standard units. We can use a combination of translating and scaling to convert any normal probability distribution to a standard normal probability distribution. Suppose x is a normal variable with a mean and a standard deviation. To convert x to a standard normal variable, we define z equal to x minus the mean divided by the standard deviation. This is our standardizing formula, and it's on page 34 of the tables. Note that x minus the mean translates the variable to a mean of 0. So for example, if the mean is 3, we're subtracting 3 so that we get a mean of 0. So for example, 3 minus 3 is 0. Then dividing by the standard deviation scales the variable so that it has a standard deviation of 1. So if the standard deviation is 5, 5 divided by 5 is 1, and so on. To calculate, for example, the probability that x is less than or equal to 1, we start by finding the value of z that corresponds to x equal to x bar 1. If z1 is this value, then z1 is equal to x1 minus the mean divided by the standard deviation. Calculating z1 is called converting x1 to standard units. Then the probability that x is less than or equal to x1 is equal to the probability that z is less than or equal to z1. And this can be determined by consulting the standard normal tables in your set of maths tables. So standard units. Suppose x is a normal variable with a mean and a standard deviation. Then to calculate the probability that x is less than or equal to x1, we convert x1 to standard units using z1 equals x1 minus the mean divided by the standard deviation. Then the probability that x is less than or equal to x1 is equal to the probability that z is less than or equal to z1. Likewise, to calculate the probability that x lies between x1 and x2, we convert both x1 and x2 to standard units using z1 equals x1 minus the mean divided by the standard deviation, and z2 equals x2 minus the mean divided by the standard deviation. Thus, the probability that x is between x1 and x2 is equal to the probability that z is between z1 and z2.